So today's topic is circle geometry, and let's start with a simple circle geometry question. Well, I don't even know if it's simple, but we're going to find out. Here is a circle with an angle at the center of 98 degrees. You need to, using what you know about circle geometry, try and find me what angle is there, and then choose the option A, B, C, or D. Okay, so we have A as an option, B as an option, C as an option, D as an option. So let's see what we can figure out about circles. I think that this thing over here and this thing over here are the same. They are called radii, and they are of equal lengths in circles. Now, what that means is that this triangle inside the circle is an isosceles triangle. So that's my hint to help you figure out what the angle A is. This triangle is, in fact, an isosceles triangle. So you know something about isosceles triangles, or I think you may. If not, we're going to go over it now. And then also you know something about triangles. So what we're going to say is that angle, and there's a couple of ways you could do this, but angle OPQ, which is basically this one, is equal to A. And then and the reason it's equal to A is that it's angles opposite equal sides. Now, you'll notice that the angle over here is opposite that side, that red one. And because this is equal, that one over there is opposite there. So this is also going to be A. And then, because you know this is a triangle, okay, I must just let people in. There's a couple of people in the waiting room. Let me just do that. Where are you hiding, people? Admit all. There we go. Sorry, guys. So now, what you know is that 2a plus 98 is 180 degrees. And again, in geometry, we generally, whenever we make a claim, angles in, or sum of angles in a triangle actually is the word. We don't have to worry too much about reasons today because it's day one. But over the course of the series, we want to start to get used to them. And then we know, well, if we take away 98 from both sides, well, we should get 82, and then A would be 41. And so the correct answer would be 41, which is C. Okay. Give me a score out of 10 about how well you understand this problem, where 10 is perfect, 0 is nothing, 5 is in the middle. Give me a score out of 10 about how you feel. Okay, so I'll receive you loud and clear. So what we need to do is just have some basic ideas, like kind of with us as we go. So whenever you have a circle, right? Whenever you have a circle, and you have two radii, those two radii are always going to be equal, and the triangle that they form is always going to be isosceles. Okay? Those two equal sides are going to form two base angles that are equal. And so this is going to come up quite a lot in terms of this. so that's something that's important to know. And let's actually, let's have a quick look at a little animation of this idea, and then I'll come back to it. So let's have a look at this little animation. So what we have here is a triangle inside a circle, and it's got two radii. And what you'll notice is if I move this thing around, you'll notice that the angles are changing, but they stay the same. Now, why are they staying the same? Because we know that both that side and, and that one over there are the same, which means, like, because they're the same, those two angles have to be equal. So what happens if we do this? They always stay the same because these radii are forcing isosceles triangles. And the official reason on the matric exam things is angles opposite equal sides, or base angles of an isosceles triangle, or here you could just say radii because they are radii, but yeah. Okay, well, let's just practice some stuff with triangles then, just to get going. So using this idea, can you solve, I want you to find me the value of angle X over there. And then after you've done that, I want you to find X over here and find Y over here. And if you can, first prize is numbers. Second prize is writing in reasons as well. So using what you know about triangles, find me what X is in the first one and then so on. So these little whisker lines are telling me that these two sides are equal, which means opposite that side is the same as that side. So X must be 68. And then we would say here, angles opposite equal sides. Angles opposite equal sides. Okay, so that's for A. Now for B, you need to find me what X is, and you also need to find me what Y is. And if possible, to do the reasons as well. So off we go, see what you can do. So to help, all right. So once you've got X, Rolani, then you've used X to help you find Y. And the other thing I'll say is that that is opposite that side, and that is opposite that side. Oh, with the reasoning, can we name the angles? You can name them, but it's not strictly necessary. I will show you the official reasons sheets in the lesson today if you want to see it. But I like to write the shortest possible one that is correct to save time. So X should be 34 degrees, and that's going to be angles opposite equal sides. So angles opposite equal sides. And then Y, well, if you know that this is 34, then the angles inside a triangle have to add up to 180, don't they? So then you would say, well, that's just that, which is 112. And the reason is sum of angles in a triangle. And so this is 112. So there are other ways of doing that, but that's the most common. And I just wanted to do some basics in terms of triangles and showing you how if you have isosceles triangles, they come up a lot in circle geometry. And so you always have to be on the lookout for those. Okay, well, let's try another one. Let's try these two. Can you solve for x and y in this first one. So we'll say x over here and y here. And can you solve for whatever x is in this one over here?
Right. So
hello.
This, if I want to take a direct route from the origin to the coordinate, I have to figure out what this distance is. But I know.
I think there seems to be a bit of a crossover
and then
there.
I moved 6 in that direction. And if I'm following my own footsteps properly, I'm going to create a 9.
That was so interesting. That's Teacher Coco in grade 10. I don't know how that got crossed over. Did anybody else hear Teacher Coco? Or was it just me who heard Teacher Coco there? That was quite funny. There must be like a parallel universe connecting us. Okay, let's see what we can do to find this one. I will do. I absolutely will. Okay. Okay, so here it feels to me like this is opposite that side and this is opposite that side. So I'm even going to write EFD. So EFD is X because of angles opposite equal sides. And that's going to be my hint for you. So this is also going to be X, but you need to find me the value of X and then find me the value of Y and put it in the chat, please.
Question. How many of us have watched?
Okay. That's so funny. Okay, so we have 2x plus 40 must be 180, and that's sum of angles in a triangle. And then we know that 2x must be 140, so therefore x must be 70. So Tsupang, I agree. Now, if we know that this is 70 and this is 70, what is y going to be then? Yeah, and it has to be 110, and the reason is angles on a straight line. Okay, so that's not so bad. Now you guys have to find what the value of x is in E. Can you do that one? So I do notice there are two whiskers here, and opposite, I call them whiskers because they're like, for me, they look like cat's whiskers, but who knows? And then here, so I think that angle must be x. So let's say LMN equals x, and that is because of angles opposite equal sides. And then we know that x plus 2x plus 20 must be equal to 180. And that is going to be the sum of angles in a triangle. So what is my x value going to be in the end is the question. I'll wait a bit of time for you guys to tell me. So I think we have to collect up all the x's. So that's 4x plus 20 is 180. So 4x, you take away 20 from both sides, you get 160. So then what is my final x value that I'm going to get? What is the final x value that I'm going to get? Okay. Okay. So it's going to be 40. Absolutely perfect. Yes. Okay, give me a score out of 10 about how you guys are feeling in terms of your understanding. 10 is perfect, 0 is nothing, 5 is something in between. Okay, cool. All right, well then we're getting there. That's good. We're getting good with triangles. Well, let's go away from triangles for a second. Let's just get some important words to do with circles quickly. So the main topic, I wanted to do a little bit of revision with triangles, but we can actually move from triangles now into circles. And if we think about some of the terminology we need to know, that would be a radius. This would be the center of the circle. I think a lot of you will have seen this before. This is the diameter. If you go across a circle and you go through the middle, that's the diameter. What is a little bit more interesting is this one over here. This doesn't go through the center. What's the word for that? So the fancy word for a straight line from one point on the circumference to another is called a chord. Yeah, but as long as it doesn't go through the center. We can also talk about a curved line between 2 points. So let me go with this bit. What is this blue line over here called? The curved line on the edge. Or actually, you know what? This is probably talking about going the whole way around. So let's say if the blue line goes the whole way around, what is that curved line called? It is called the circumference. Yes, I'll even circumference. And then if it's just a small piece, if it's just like from here to here, that is called an arc. That's called an arc. And then something else that you need to know about is that a chord divides the circle into two sectors. So this would be called the minor sector. The green thing is the chord. And then the major sector would just be on the other side here. That whole area is called the major sector. So chords divide up circles into sectors. Okay, so we've got that. Oh, and then there's one other new thing. If you have a straight line and it just touches the circle in one point, the fancy name for that line is a tangent. Yes, Sange, you're quite right. So sometimes you hear people say to each other, don't go off on a tangent. What they mean is don't get close to something, start talking about it, and then go talk about something else. That's kind of where that saying comes from, because a tangent gets close to a circle, touches it, and then goes away from it. Okay, so that's just some terminology that you need to be aware of. So that's not a problem. Let's do some multiple choice questions about this terminology. So which of these four options do you think is correct? All right, so I think clear consensus B is the correct answer. Awesome. Okay, let's go to the next one. What is another name for the perimeter of a circle? What is another name for the perimeter of a circle? Yeah, this is just going to be the circumference, because the fancy name for the perimeter of a circle is the circumference. Awesome. Okay, so that's fine there. Oh, okay, I'll come back to that one in a moment. Oh, let's have a look. What other terminology have I not spoken about yet before I move on to the... Oh, a sector. Okay, a sector is if you have two radii and they go out like that, the area between them is called a sector. And you also have a minor sector, like in red, and then you would have a major sector in blue. So that's when we talk about sectors, sectors are divided up by radii, whereas if we talk about segments, segments are divided up by chords, where the green one is the minor segment and the blue one would be the major segment. And then I've mentioned tangents already earlier on. A tangent is just a line that touches the circle in one place. Ooh, what about this? What is that line called? It cuts the circle in two places. Bonus points if you get this one right. Or not a segment, but you're close. Tangent and then secant. So if this is called a tangent, if it cuts it in two places, it's called a secant. Yeah, perfect. All right, everyone. Let's do one more triangle geometry question from the beginning before we take our break. I think we need one more, one for the road here. And we can take our break. No, not that one, not that one. Let's do this one. Let's do this C. Can you find me the value of X, Y, and Z? Because you are going to find that triangles are often hiding inside circles, and that's why we're doing so many triangles today. So find me the value of X, Y, and Z with the reasons, thinking back to grade 9 geometry. Now remember, watch out. The two sides that are equal are here and here. All three sides are not equal. This bottom side is a different length. So I would probably start with the X. Why don't you find me what the value of X is first? Okay, so I think that the x is 180 minus 126 because it's angles on a straight line, which means this should be 54 degrees. Yep, so that's 54. What does that mean about the angle y? What does that mean about the angle y? What does that mean about the angle y? Well, y has to be 54 degrees for the same reason, right? So if we look at, well, not the same reason, actually, I lie. But for, if we think about this, this is angles opposite equal sides. Why is this not behaving? Sorry, my computer's being difficult. So this will just be, oh, there we go. Angles opposite equal sides. So what is Z going to be then? Well, I think it's just the sum of angles in a triangle. So it will be 180 minus this, which is going to be minus 108. So that should be 72. And the reason is sum of angles in a triangle. So this would be 72 degrees. All right. So that is our first half of the lesson. What we need to do now is take a moment to just stand up and stretch. We did quite a bit of stuff in the time. And so what I want you to do is just join me in standing up. Take some nice deep breaths. So let's breathe in. Breathe out. And breathe in. Breathe out. Breathe in. Okay. Then let's roll our shoulders back, just loosen up our shoulders. And then we're going to roll our shoulders forward. And then we're going to put our arms out like this. And we are going to go round and round like this. And then we're going to change them back like this. Okay, and then what we're going to do is we're going to rotate from side to side like this. And as you relax, you're going to feel your body go further. Okay. Then what should we do? I think what we need to do is we need to do some heart rate raises. So we need to do some jumping jacks. And so a jumping jack is just going to be like this. And so we are going to do 15 of those in 3, 2, 1. Let's go. 2, 3, 4, 5, 6, 7, 8, 12, 14, 15. And that is that. Okay. I do feel like the blood is flowing and that my brain is happier. Before we head back to the work, though, let's just have a go at 2 Maths 24 puzzles. So can you get me the answer to these Maths 24 puzzles? If you can, put them in the chat. Who can solve this puzzle? So either red or blue cards, you have to use all four numbers to make 24. So it's a pang. Tell me what is your, how do you get the red one to make 24? So 4 plus 2 is 6. Yep. Oh, so 4 plus 2 is 6. And then what comes next? 3 plus 1 is 4. 6 times 4 is 24. Okay. Awesome. Awesome, awesome, awesome. Okay. What about the blue one? Can anyone do the blue one? Any ideas? That's a 6 and a 7 and a 4 and a 2. I can give you a hint if that's helpful. I think 7 minus 4 is a good place to start. So if you use the 7 and the 4, how would you get to 24 using that? So you use 7, 4, but now all you need to do, and everyone else has got this, but yeah, you go 6 plus 2 is 8, and then 3 times 8 is 24. Awesome. Okay, let's go back to the second half of today's lesson. So, as we look at a circle, I want to introduce you to something called the angle at the center and the angle at the circumference. So I'm going to draw a circle and I'm going to choose 2 points on the circumference. And I'm going to call them C and D. Now, I can connect C and D either by using the arc CD, or I can draw a chord CD. The only difference is that a chord is a straight line, an arc is a curved line. Now, when we say a chord or an arc subtends an angle at the center, all we're saying is that it makes an angle from the 2 points it starts with, and that's an angle at the center. But then an angle at the circumference based on the same chord or the same arc will look like this. And there is a relationship in circles between the angle at the center and the angle at the circumference. And so that's what we're going to have a look at. And the fancy word that they often use is they say that the arc CD or the chord CD subtends an angle at the center, which is the pink one, or it subtends an angle at the circumference, which is the yellow one. Now, as we look at the animation now, I want you to see if you can figure out what the relationship between the angle at the center and the angle at the circumference is. So let's have a look. Okay, GeoGebra is our friend here. Now, at the moment, that looks like it does, but if we just look at one scenario, that's not going to be very helpful. So what we're going to do is I'm going to move, oh, I can move that. Interesting. It doesn't change the angle. So that's one interesting thing. Sure. Okay, what if I change the D? What does that do? Let's change it down to this. So if I move the point D or the arc CD, it definitely affects the angle at the center, but it also affects the angle at the circumference. So let's keep going up to there. Okay, so angle at the center, angle at the circumference, there's definitely a relationship. What if I took this point E and I went like this? Ooh, that doesn't even matter. So the angle C, the arc CD makes the angle E at the circumference, the angle A at the center, and kind of, it's interesting. Okay, who thinks they've noticed the relationship between the angle at the center and the angle at the circumference? Please repeat the part from the chord. Oh, so when we say that the chord CD subtends an angle, we say it's the base on which the angle is made, and subtending an angle at the center, let's often call the center O. The angle at the center subtended by the angle C, the chord CD would be the pink one. Subtended by the chord CD at the circumference would be the yellow one. I saw a hand go up, so let me go and look at that. CM Tanda, yes, what do you notice?
So I noticed that the angle below the angle A is equals to 2 times of angle E.
Yeah, that's exactly it. So the angle at the center is double the angle at the circumference, basically. Yeah, that's exactly that. Perfect, 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 perfect. Okay, let's see how a question might look that uses this idea. So you can tell me, what is the size of angle H using the idea? Oh, thank you, Tsepang. You also got that one right. What is the size of angle H using the ideas that we have learned about so far today? So this is the arc. Let's call this like CD. Those are the 2 points that are subtending the angle. And there's an angle at the center that's subtended. And then there's also an angle at the circumference, which is subtended. And we just said the angle at the circumference is half, or the one at the center is double. So that should be 100, which means that makes that the correct answer. Now, the reason that we use when we use this fact to make a claim, we say angle at center equals twice angle at circumference. And you'll notice that I'm using the abbreviation for angle, then 2 angle over here. And then I'm also using an abbreviation for circumference over there. And so that's the sort of, but we'll get more into the reasons as we go, but just so that you are aware of them. Okay, find me the value of x in this question. Find me the value of x. Well, BC is the arc that it's being based on. It subtends this angle at the center and this angle at the circumference. So we know that x is actually just going to be 124 over 2, or 62 degrees. And just to see that reason again, angle at center equals twice angle at circumference. And that is that one. Give me a score to 10 about how you're feeling. 10 is perfect. 5 is kind of okay. 0 is nothing. How are you feeling about these ideas that we've done about angles at the center and angles at the circumference and some of the vocabulary that I've been using? Okay, cool. All right, so then let's keep practicing. So that's good. Can you answer this multiple choice question? Which of the following is a correct way to write the unlabeled angle y? So that's y over here. Oh, in terms of y, sorry, in terms of y. So they basically want to say, look, you've got the yellow one, it's y. What is the green one in terms of y? So remember, this one over here is twice the size. And so this would just be y over 2, in which case the answer should be C. And then the arc that is kind of the angles are based on is going to be this green one over here, essentially because you've got that, and then you've got that one over there. Okay, so the idea is starting to make sense. This is a little bit harder, but we're going to give it a go. Can you find the value of x in this diagram? Knowing what you know about circles and what you've learned about this relationship between the angle at the center and the angle at the circumference. What do you think the value of x is? I want you to try and find it. Can you all hear me? Amelia, I am with you. Exactly. Um, okay, fantastic. Okay. So apologies about that. I don't know what happened with the bits and pieces, but anyway. If I double this, I get 2x. So now what I need to do is, if I know x plus 22 is 2x, I'm going to leave the 22 there and go 20, and I'm going to go 2x minus x, and then I'm going to say, well, actually then x is 22. And that makes sense because if this is 22, this one over here would be 22 plus 22, which is 44, which is double the size of the angle. So that was a bit of a sneaky one, but I think you all kind of get it now in terms of, well, maybe you don't get it perfectly, but you get the basic idea. Okay, now let us do this one. No, it's a pang. Yes, it's got you. What is the size of the missing angle x here? Oh, Stephen. Okay, I'll go back to the other one now and do it again. So if I the previous one, which was, I think maybe some of you lost me for a second. So I'm just going to go over it quickly. So if you look at this, the big angle here is x plus 22. So I've written it down over here. Now the small one is x. But because it's half the size of that one, I need to double it in order to make the two equal. And then what I do is I bring this across, and then it becomes negative x. And what's 2x minus x? It's just x. And what is left behind? It's just 22. Now, if that is 22, that makes sense because here it's 22 plus 22, which actually is 44. And so the angle at the center is double the size of the angle at the circumference. Is that helpful, Stephen? Okay. So just to go back to this one, the correct answer here would be C, which is 84. So that's 84. Okay, now, sneaky one. I want you to find for me X and Y here. Oh, and ABCD has its own special name, which I'll talk about now. But let's see, can we find X and Y? We probably need to know what this angle is, don't we? What is the angle AOC reflex going to be? Just to help you out, what do you think the angle AOC reflex is going to be? I think that there's something called the angle in a revolution. And so what you actually need to do to get that angle is it's going to be 116. Yeah. So that's going to be 116. Now, can you work out what X and Y are? Okay, be careful here because there are some sneaky things around. So let's say we have the arc AC and it makes an angle like that at the center, but an angle like that at the circumference. I think X is going to be 50, not even 50. Is it 50? Wait, what's 116 divided by 2? Because if you look at it, the relationship is between this one and this one. So 50, it's 58, yeah. So X is going to be 58 because it's half the size of 116. Okay, so X is 58. Now I should put the reason in, but I'm just running out of space. But now, here's something interesting. Okay, we know that this is 58. What is the size of angle Y going to be? And this is where it is a little bit sneaky. And it's almost like it's a backwards thing I'm going to show you now. So imagine you had that arc, and then you subtend that angle at the center, which is 244. Oh, that's too big. Let me make that smaller. So imagine you have the arc that goes the whole way around like that, the major arc. And you know that this angle is 244. Okay. You can also subtend an angle at the circumference over here using the big green arc. Can you see that the Y is going to be half of the 244? So basically, Y is going to be 122. Because the relationship between the angle at the center, 244, and the angle at the circumference is that one. And then on this side, it's the 116 with the 58. A little bit tricky to see, actually, that one. But it is correct. Yes. Okay. So now Tsepang, I suspect, knows about something called a cyclic quad. And this is where I want to end today's lesson. if I look at this quadrilateral ABCD, this quadrilateral is not a normal quadrilateral because all its vertices are on the circumference of a circle. And so we call this type of quadrilateral a cyclic quad. This is called a cyclic quad because all 4 vertices are on the circumference of a circle. Now, we're going to cover this in later lessons, but a cyclic quad's opposite angles always add up to 180. So what Zapang, I think, knows is that if that is 58, the one down here is just 180 minus 58, which is 112. Sorry, not 112, 122. But we're going to get to that in later lessons. For today, I was just using the theorem or the fact that the angle at the center is twice the angle at the circumference. All right. And I think that is, maybe we may do one more just to, let's just do this last one here. And then this is the other shape. So if we're going to finish with this question, we've got the arc AB, and if the angle at the circumference is 60, what is the angle at the center going to be in this particular shape? What is going to be? So you'll notice that it's almost like it looks like a bow tie almost. This angle over here is at the circumference. It's 60. This one over here, angle X, is going to be 120. And that is another variation of this theorem. So I should probably just show you the 3 main variations of this fact or this theorem. Is the first variation is what we call the arrowhead, which looks like that. Then you can have the one now like we had here, where you have like almost looks like a bow tie. And then it's also possible to have a shape where it sort of bends back to being that one is at there, and then this one is up here. And those are the 3 main shapes where there's a relationship between the angle there and the angle there, or you could say the angle there and the angle there, or you could say the angle here and the angle here, where the red one is the angle at the center, the blue one is the angle at the circumference. And we're going to go further with that in the next lesson.